Hello, my name is Jurgen Strum. I come from the University of Freiburg in Germany, and I'm working on learning kinematic models for articulated objects. Articulated models can help a robot to understand how objects like doors and drawers move, and that can help a robot to actually open and close drawers in the kitchen. Previously, I made the robot learn such articulation models from data that we got from a motion capturing studio, which was good. But now we want the robot to be able to learn these models with the sensors that it has on board. The robot has a stereo camera on its head with which it can record a scene in front of it, and from that it can extract point clouds. And we were thinking about using these point clouds to actually find drawers and doors in it. In our first approach, we segmented out planes from the point clouds that we got from the stereo camera, and within the planes we looked for edges using a Kenny operator, then looked for lines using a Huff transform, and from that we got intersections of pairs of lines and used chamfer matching to find the pose of a rectangle. This approach was pretty complicated, and it turned out that it didn't work too well for doors, so we came up with a second idea. In the second approach, we did something much simpler. We picked a random point in a plane, started with a very small rectangle, and then incrementally grow this rectangle and changed its position until we found a good fit. After the search has converged to the final position of the rectangle, we compute the fill ratio of the rectangle and filter out those rectangles that have not enough support from the point cloud. We found that the second approach worked much better and also on a larger variety of objects. So it worked on drawers and doors, but also on books and boxes. The tracker outputs a sequence of rectangle observations that belong together, that come from the same object. And now we can start an articulation model learner that will discover from which type of object this track actually came from. So in this case here in the video, the articulation model learner has discovered that it was a drawer that was moved out of a cabinet. I have presented here a very simple, robust approach for finding rectangles in point clouds. This is still ongoing work. We will publish a paper on this shortly. In the meantime, you can check out the software package called Planar Objects in ROS, which is freely available as open source.